Hello, abstract algebra students. We will now look at the well-defined property for double multiplication. And it turns out that double multiplication is well-defined on R. We will claim this and prove this now. The proof works very similarly to the proof for double addition. So we've got the operation double multiplication given by the equation A star B equals 2AB is well defined on R. This means that we want to show, if we apply the definition of well-defined to the set R, we want to show for all A, B, Y, Z in R, if both A equals Y and B equals Z, then A star B equals Y star Z. Okay. This again is a statement that begins with a for all quantifier. So we begin by letting A, B, Y, Z in the set of reals be given. So our proof begins, let A, B, Y, Z in the set of real numbers be given. We have an if-then statement that we want to prove. So we assume the if part and we try to prove the then part. Assume that both A equals Y and B equals Z. Now, if you don't see how to prove the then part right away, work backwards from where you want to show. So again, by doing scrap paper, our scrap paper here where we want to end up is A star B is Y star Z. So working backwards from the definition of double multiplication, this gets us 2AB equals 2YZ. Now, we can break this up. We know that 2 equals 2. So if we can get down to AB equals YZ, we can multiply both sides by 2 using the multiplication as well defined to get 2AB equals 2YZ. So we really just need to figure out how to go from A equals Y and B equals Z to AB equals YZ. And that's just the use of multiplication being well defined. So now that we've worked it backwards on scrap paper, each sentence writes itself. Since we know that all of A equals Y, B equals Z, and multiplication is well defined on R, it follows that AB equals YZ. Since we know that 2 equals 2, AB equals YZ, and multiplication is well defined on R, it follows that 2AB equals 2YZ. Therefore, since we know that 2AB equals 2YZ, by definition of double multiplication, we may conclude that A star B equals Y star Z. And that ends the proof because we have let A, B, Y, Z, and R be given. We assumed the if part, we proved the then part. So let A, B, Y, Z, and R be given. Assume that both A equals Y and B equals Z. Since we know that all of A equals Y, B equals Z, and multiplication is well defined on R, it follows that AB equals YZ. Since we know that 2 equals 2, AB equals YZ, and multiplication is well defined on R, it follows that 2AB equals 2YZ. Therefore, since we know that 2AB equals 2YZ, by definition of double multiplication, we may conclude that A star B equals Y star Z. Notice again, when we do well-defined proofs, we start out with two pairs of elements being equal. And the goal is by doing the same thing to both sides of the equation, combining equals with equals, we build up the equation that we want, A star B equals Y star Z, and we do it by either adding, subtracting, multiplying, or dividing equals from equals. In other words, this operation, double multiplication, inherits it being well defined from the fact that ordinary multiplication is well defined on R. Okay, we will look at closure next.